Hi seniors. So today we're going to do another day of converting in slope-intercept form and then graphing those equations, but we're really going to focus on converting today to make sure that we get our equations in slope-intercept form because we can't graph them until we master that skill. So let's go ahead and jump in. On your notes page, go ahead and draw your line. I don't have a line drawn here, but go ahead and draw it on your notes page and go ahead and write converting in slope-intercept form. So again, I always want to remember my equation. My slope-intercept equation is always y equals mx plus b, where m, oops, my pen, where m is my slope and b is my y-intercept. Remember, my y-intercept is the point on the graph where my line crosses the y-axis, and my slope is the steepness of a line. So make sure you have the equation written down and then what slope and the y-intercept equal. When I am converting equations into slope-intercept form, I always want to remember to isolate y on one side of the equation by itself. You want to get y on one side of the equal sign and everything else on the other side. So let's go ahead and do an example. Go ahead and write example 1 on your notes page, and then 4y minus 12 equals 3x. I see immediately that this problem is not in proper slope-intercept form because it does not match my equation where y is isolated on one side with my x and my constant on the other side. So I need to solve for y. The first thing that I need to do is get y on one side of the equal sign by itself. So I need to get rid of this negative 12. And of course, you'll remember from solving equations, the way that I get rid of the negative 12 is I do the inverse operation, and so I'm going to add 12 to both sides, since the inverse of subtraction is addition. All right, my 12s will cancel out because negative 12 plus 12 is just 0. I'm left with 4y equals 3x plus 12. I'm almost done, except that y is still not isolated because it has a 4 attached to it. So these two things, 4 and y, are squished together by multiplication. In order to get y by itself, I have to do the inverse of multiplication, which is division. So I'm going to divide 4 on both sides. My 4's will cancel out. I'm left with y equals, and here's the part that a lot of us are missing. When I divide 4 on this side, I have to divide both things by 4. So I have to divide 3x by 4 and 12 by 4. So 3x divided by 4 is just going to be 3/4 x, and then 12 divided by 4 is a positive 3. Now I have my equation. Y equals 3/4 x plus 3, where 3 is b, which is my y-intercept, and 3/4 is my slope, or m, in this example. Let's do another one. All right, go ahead and write example 2, and then 6y minus 18 equals 12x. Again, I see that this is not in proper slope-intercept form, so I know that I'm going to have to move part of this side of the equation to the other side. I need to get y isolated, so I need to get rid of this negative 18. The way I get rid of the negative 18 is I do the inverse operation, and I add 18 to both sides. My 18s will cancel out because negative 18 plus 18 is just 0. I'm left with 6y equals 12x plus 18. My pen is your pen. Make sure you have all this down. Y is still not isolated, so I know I'm going to have to divide by 6 on both sides. My 6's will cancel out. I'm left with y equals 12x divided by 6 is going to leave me with 2x. And then 18 divided by 6 is going to leave me with a positive 3. Since my equation is now in slope-intercept form, I'm good to go. We're going to work on graphing these later, but I really want us to get down this converting part. Let's do one more example. All right, go ahead and write example 3, and then 2y plus 4x equals 8. Again, I see that this equation is not in proper slope-intercept form, which is y equals mx plus b. I need to solve for y. In order to get y isolated, I need to get everything else on the other side of the equal sign. So this positive 4x, I need to get rid of it. The way I get rid of a positive 4x is, again, I do the inverse operation. I subtract 4x from both sides. My 4x's will cancel out because 4x minus 4x will just give me 0. Make sure that you carry your variable with it. You can't just subtract 4 because then you still have a variable. I'm left with 2y equals 8 minus 4x. Y is still not isolated, so I know I need to divide by 2 on both sides. All terms are getting divided by 2. My 2's canceled out. I'm left with y equals 8 divided by 2 is just going to leave me with 4. And then negative 4x divided by 2 is going to leave me with negative 2x. This is almost in slope-intercept form, but I want my x to be the first term on the right side of the equal sign, so I'm going to rewrite my equation to be y equals negative 2x plus 4. All I did there was I flipped my terms, and I kept the sign. So my negative sign follows the 2x. All right, let's do one where we graph. Because remember, the whole point of converting is so we can graph. All right, go ahead and write 4y minus 8x equals 16 on your notes page. This will be our last example. Again, I see that this is not in proper slope-intercept form because y is not on one side by itself. So the first thing I need to do is I need to get y alone. So I'm going to have to get rid of this 8x. The way I get rid of it is, of course, I add it to both sides. My 8x's will cancel out. I'm left with 4y equals 16 plus 8x. In order to solve for y, I know I need to divide by 4 on both sides. Everything gets divided by 4. My 4's cancel out. I'm left with y equals 16 divided by 4 will just leave me with 4. And then 8x divided by 4 will leave me with 2x. This is almost in slope-intercept form, except I want to flip my terms, so my x is the first term on this side of the equal sign. So I'm just going to rewrite it as y equals 2x plus 4. Now, I want to graph this equation. So I need to figure out which one of these terms is my slope and which one is my y-intercept. Well, if I go back to my equation, I know that b is my y-intercept. So 4 in this case is going to be my y-intercept. And that is always my starting point. And that means that 2 is going to be my slope. And remember, whenever you have a whole number as your slope, that is the same as 2 over 1. That is the same thing, 2 over 1. All right, so I know in order to graph these, I have to start at my y-intercept. So I'm going to put a dot on my graph where y equals 4, which is right here. Now, I know that my slope is going to be 2 for my equation, but I need to figure out my rise and my run. We already kind of hit on this. If I have a slope of 2, that's the same as 2 over 1, where 2 is my rise and 1 is my run. That means for every plot that I point, I'm going to rise 2 points and go over 1 point, and I'll have a perfect line. So let's do that. Go back to your y-intercept, that's always your starting point, and go up 2 and over 1. Up 2, over 1. Up 2, over 1. I could do this all day long, and it's going to give me a straight line. But if I want to extend my line on this side of the graph, which we all need to start doing, I just do the opposite. I go down 2 and left 1. Down 2 and left 1. Down 2, left 1. Down 2, left 1. Down 2, left 1. I could do this all day long, but again, you see how I'm getting a perfectly straight line. So, when you're doing these equations, make sure that your equation is first in slope-intercept form, and then you can start graphing it. All right, guys, let's go ahead and practice. We're going to be working in pods today. I'm really excited about it. I think you guys are really going to master it. So, let's get to work.